Section 2.1 is called Numeration Systems. And what we're going to be doing in this section is we're going to be looking back at a historical sort of perspective at a few different numeration systems that led up to the one we use today. We will also talk in this section and a part of it about our numeration system that we use today. So let me talk first about our system a little bit, and then we'll kind of look backwards at where some of the pieces came from. Our system is called the Hindu-Arabic numeration system. Sometimes you'll see the word Hindu replaced with, I can't remember what the other word is that you sometimes see. Arabic uses Hindu, but that is not always what's used there at the beginning. This is a numeration system we use today. It was developed by the Hindus and then transported to Europe by the Arabs. Our numerals are constructed from 10 digits. What are the digits that we use in our numeration system?
0 through 9.
Right, 0 through 9. So I mentioned that because we don't actually have a digit for the number 10, right? That's a 2-digit number. So when we talk about this issue later, that's going to come back up again. Our digits don't actually include a digit called 10. The place value, our system has a place value system, and so it's based on the powers of 10. So the number, it's the number base of the system. So in our system, we have, right, the ones place, and then we have the tens place, and then we have the hundreds place, but 100 is the same as 10 squared. We have the thousands place, that's 10 cubed. And the reality is I could also write 1 as 10 to a power. Do you remember what that would be? It's 10 to the 0. So the fact that we have these bases of base 10 is because we have a power 10 or a base 10 number system. We're going to look in another one of our sections, I can't remember if it's this one or a different one, at different bases besides base 10. Any idea why we might use base 10? No, because we could do that with any number system. There's 10 fingers. That's why we use base 10. We're going to see a couple other systems where they don't use base 10, but like let's say, for instance, that when God created us, he created us with no thumbs. We'd probably be using base 8. I mean, that's the reality. My brother tries to give me a hard time every now and then and tell me that I should make you all come to class in flip-flops so that we could talk up to 20 and it would make sense to everyone. So he's a card, yes. But this base 10, this idea of doing these powers of 10 down here comes from our exponentials, which we've looked at this once before, but just as a reminder, remember when we have a to the power of n, this means we have a multiplied by itself n times. We took a look at that back in section or in chapter 1 at some point. All right, so what we're going to do first is we're going to look at a very old number system, and this is the Egyptian numeration system. The Egyptians are the ones who did things with hieroglyphics, and so they have lots of cool symbols. I have a necklace actually that's got hieroglyphics and it's spelling my name out. And they just have some really neat things in their system. Their system's actually really easy to look at the number, know what it says, or look at our number and write it in their system. So they have that benefit to them. So to talk with, we're going to have symbols for every single one of these different red descriptions listed. The first one, the vertical staff, their Egyptian numeral looks like this. It's like a tally mark. And if you were guessing, what would you guess that value is?
1.
It is 1. Their next numeral is actually, we're going to refer to it as a heel bone. It looks like this, kind of like an upside down U. And it is actually the value 10. So when you see a heel bone, it's the number 10. So they actually have a numeral for 10. We don't have that. We don't have a numeral for 10. They do. The next one is a scroll. Now, your book draws the scrolls like this. There are some other books that don't draw them that way. They draw them a little bit differently. For the Egyptians, it did not matter if the scroll was drawn like that or sort of drawn backwards of that or upside down of that. It didn't make much difference. But this is how you'll see your book do this. The scroll has value 100. The next one's called a lotus flower. It may be the one that I have the most difficulty in drawing to look like theirs. But it looks something like that. like a flower, you know, that kind of droops. So I'm not going to be super picky on your pictures, but try to make them, you know, reasonably similar to the ones that are there. I'm no artist, that's for sure. Okay, so if you look at those values on the right, they seem to be sort of like a pattern going on. What do you think this one's worth? The value. It's 1,000, right? The next one's a pointing finger, and it's probably the one that looks the least like the description. So it looks like this, and that's terrible. We're going to try that again. I don't know if that's all much better, but that's pretty much what it looks like. If you look in your textbook, this is kind of what it looks like. And you can kind of have the image, right? It's looking like this, right? If you put your hand up in the air, you can kind of see where that image is coming from. You know what the pointing finger's worth, though, I'm sure. What is it? That is 10,000. The next one they're referring to as a polywog or a burbo. It looks like a fish, or sometimes some references I've seen will call it a whale. And so the image that you see in the book looks something like this. A tadpole or something, right? Okay. What's he worth? 100,000. He's 100,000. So you see one of him, and he's 100,000. The last one that we have is an astonished man, and I think he's astonished because he's worth $1 million. So this is his value, and I'll draw him the way that your book does. I think this is the way your book does. I've had a couple of books draw this one a little bit differently, so I'll draw this one. It looks kind of like a woman, actually. Another textbook that I have seen draws it like this. He's like, I don't know if he's jumping or what, but he's excited. Yay, he's excited. So draw him somehow like that. One of those is fine. Okay, so I want to show you how nice and easy this system is to use. So we're going to first consider a value. The value we're going to consider looks like this. Now, if you wanted to, I bet you could tell me how much this is worth, and you could probably do it pretty quickly. So just for the sake of saying that I said you could, let's do it. Do you know what that value is? 310. That's what that value is, 310. Right, 3 scrolls are each worth 100, and the heel's worth 10. Now, for the most part, your book, and I'm not going to ask you to actually tell you that, but what I do want to know is they're going to ask you in several places where they ask you what's the number that comes before this number, and what's the number that comes after. And you really don't have to know what this number is in our system to be able to answer that question. Now, in both of these cases, one of them, or I'm sorry, in this example with the other ones that we're going to follow, one of the two directions, either the before or the after, is easy, and the other one's more difficult. Which one of these two should be simple, easy, on this particular problem? The after is easier. What would be easy about this to do after? Yeah, you just have to put the tally mark and you're done. So on the number that comes after this, it's going to look like 3 scrolls, the heel bone, and a tally. Okay? That's the number that comes after. So I just have to put one extra symbol on the end, and I'm done writing the number that comes after. Now, I'm not suggesting that the number comes before is terribly difficult, but it's more challenging than this one. Okay, so what is the number that comes before this going to look like? The 3 scrolls. My scrolls are not looking so good today. And then what else?
9 tallies.
Yeah, and then 9 tallies. So what you actually had to do is you had to do something that kind of looks like what we do when we borrow. Right? You had to turn at least in your mind, you did something to this effect where you said the heel bone's worth 10. That's my last symbol. And I need one less than that, so that's 9. So I'm taking a heel bone, I'm turning it into 10 of these sticks, and I'm taking one away, so I've got 9 of the sticks left, 9 of the tallies left. Now, comment of here on the bottom is that there are benefits and there are sort of drawbacks to each of these systems. I would definitely say a benefit to this system is I can look at the number and I can count things pretty quickly, and I can figure out how that correlates to my number system. But I've written down here a drawback. This part A numeral does not really seem to be an especially efficient use of my time or paper. Okay. If I had something that had lots of these symbols with the 9, like 9,999, we're going to have to write out 9 flowers and 9 scrolls and 9 heels and 9 sticks. That's just, it's cumbersome, right? It's just not terribly efficient. Okay, so efficient means good use of your time is what it really means. All right, so let's go on and take a look at another system. Maybe one that's a little bit fewer symbols anyway. We'll start with that. This system, Babylonian Numeration System, has 2 symbols. 2 and only 2. One of their symbols looks like an upside down triangle, and they do fill it in. Okay? Now, as we work, if you don't fill it in because it becomes sort of labor intensive to mess around with doing so, it's okay. But they do have them filled in. And this Babylonian numeral that looks like this upside down triangle has the value of 1. Their second symbol looks kind of like a less than sign. It's like thickened a little bit, but it looks something like this. And this one has the value of 10. Now you might look at that, in fact you should look at that and say, okay, but how would I write the number 100 or 10,000? Surely I don't write out that number, any of those symbols, that many times. And the answer is no, you don't. This is a place value system. So a place value system is like what we use. We use a place value system. So if we want the number 100, we still use our same 9 digits, right? We just put a 100 in a certain location to represent that. That's what it means to have a place value system. We only use those same 10 digits over and over again, but the place where they're located means something different. That's what they do too. So they have a place value system. The second thing they do, though, is they have a base 60 system. Okay, base 60. We don't use base 60. We use base 10. Now, I want to flip back over here when we were talking about this base 10. When we talked about our base 10 number system, our place values of powers of 10, we wrote down that the first symbol, the first place value to the right, was the ones place. And then we did 10, and then 10 squared, 10 cubed, and we could keep going up from there. So if they're doing a base 60 system, they're going to do the same thing, except what will be different? Yeah, we'll have to use the 60 as the base instead. So we'll still start with a base of 1, because that's still, not base of 1, but a place value of 1. That's still 60 to the 0. But then from there, instead of putting 10 as the next placeholder, it's 60. And then this would be 60 squared and 60 cubed and so forth. Now I'm going to draw you a picture here in a moment to tell you when you see one of their numbers how you figure out where you are and what you're doing. But basically what you would do is you would use these 1s and these 10s inside of each of these locations to represent how many there are, just like we do. If we want 300, we put a 3 in the hundreds place. Okay? That's basically what they're going to do too. But it's going to look a little different because you're not familiar with it. So I'm going to write down a value and we'll work on this one together. This one's going to look like 1 triangle. Five of these sort of look like less than sign things. And then we'll do 8. Let's make it 9 triangles after that. Now, here's sort of some of the problems that are going to come into play, but let me tell you what we're going to do in class to interpret this. And then after we do the parts A and B here, I'll tell you, we'll read this bottom part together and talk about some of the weird things that are problematic with their system. They always put the bigger number in front of the smaller one, okay? So these less than signs are worth 10, right? And these triangles are worth 1. So right here is a natural place where it for sure has to change place value, because that's a 1 on the left-hand side, and there's 10s that follow it on the right. Are you with me so far? So we can't go smaller to bigger. It's always bigger to smaller within the place value. So the natural approach is to think of this being the first place value and this one being the second. Okay, so let's just count what's here to have an argument or think about what we've got going on. What is the number on the far right with all of the crazy long number of symbols here? What do I have over there?
59.
I have 59. Everybody with me? There's 59. There's 5 tens and there's 9 ones. Okay, so this number over here right now is 59. What's the number to the left-hand side of that vertical bar I drew? 1. So basically what we're saying is there's 160 and there's 59 ones. So if you imagine sort of like, I like to think about it in terms of money. We don't have a $60 bill, but pretend we did, all right? Well, then we'd have 59 ones and we'd have one $60 bill, something of that variety, okay? All right, so let's answer these two questions, and then we'll talk about some inherent problems with the way that we're even describing this. First one says, what Babylonian numeral comes before this value? What's it going to look like?
One less triangle.
Yeah, just going to have one less triangle. Now, it's cumbersome to write, but it's easy to process. Just take away a triangle, right? Kind of like on the last example, all we had to do was add the stick to the number greater than. So for this answer, we're going to have the triangle, 1, 2, 3, 4, 5 less than signs, and then we're going to have 8 triangles as the number before. The next thing that it says is what number comes after this value. That's a good question. So you're recognizing that I wouldn't just add a triangle, because if I added a triangle, I would have 10 triangles, and it would be more helpful to write 10 triangles as a less than sign, right? So I get that. That makes sense. But then how many less than signs do you have?
6.
So what's it worth?
6.
60. So the symbol is actually going to look like 2 triangles. So imagine what happens when we do this with our dollar bills. If I give you $9 bills, and then I give you one more, for anything like me, you probably don't really like to have 10 $1 bills. They take up a little bit more space than if you had simply had a 10. It's the same thing, right? All of a sudden now we've got 60 ones. We don't want 60 ones. I'd rather have the $60 bill. Okay, that's the equivalent of what we're talking about here. Once we max out the place value, which is 59, in order to make it any bigger, we have to add 1 to the column on the left of that side. That's what we do in our system, right? Once we hit 10 items, 10 ones or 10 tens, we don't write a 10 in the tens spot. We write a 0 in the tens spot, and we add 1 to whatever's in the hundreds spot. And that's what we're doing here. We're zeroing out what's after my vertical bar, and we're adding 1 to what's before. But this creates a problem. Because that looks like 2 to me, too. Yeah, like we need to place something that just holds that spot. We have one in our system. What do we use? We use a 0. Yeah, we would use a decimal for other things, but we use a 0 to hold the place, right? They don't have a 0. That's problematic. So this number here could be interpreted as 2 times 60, which is what we meant it to be, right? We meant it to be 2 60s. But it also could be interpreted as 2 times 1, which would be 2, like Devin said. But you could also say, well, maybe one of those is in the ones place and one of them is in the 60s place. Now, this one we could sort of get away with if we were being consistent how we created our numbers and sort of leave a space there, right? Or if we want to be really creative, we could maybe put commas like we do with some of our stuff, right? They didn't do that, though. And so there's this ambiguity in this. So I don't know about you, but if I'm doing bookkeeping in Babylon, that wasn't right. If I'm doing bookkeeping in Babylon, this is a big problem, right? I mean, this is not good. All right, let's take a look at the Mayans.
Are we going to have questions like that on our homework?
Yeah. Like what? Questions like what? What do you mean?
What is that? So where you're going to have to interpret whether
No. I mean, even like when I told you this, let me take a look at this problem over here. I told you for sure that vertical bar that I drew in needed to be there, and that's a true statement. That's the only one that absolutely must be there, right? Because it has a smaller value before, a bigger value afterwards. So when we interpret what we're looking at, that's what we're going to do. The reality is in their system, there might be more vertical bars that separate things that we wouldn't know that are there. I mean, that's really unfortunate. So we're going to kind of like understand this as being putting in as few of placeholders as possible. That's how we're going to think about it. Yeah. All right, let's look at the Mayans. The Mayans do solve one of these problems that are happening with the others, but they still got some issues. Their system is interesting. They've got a system where they have dots and lines. Okay, so they've got a dot, and that's worth 1, the value of 1. They've got a line, and it's a horizontal line, and that's worth a value of 5. And then they've got what looks, depending on the resources you sort of look at, it looks like a clamshell, something like that. And I already told you I'm not a good artist. This is a 0 placeholder, so it actually has a value of 0. So that would have actually solved at least a little bit of what was going on in the last problem, right? At least for the problem that we did, whereas we didn't have a way to say there's nothing in this place spot. So that does help some things out. It doesn't help everything out. They have a place value system. Okay? Place value system, just like we do. Theirs is a modified base 20 system. So they sort of have powers of 20 as their bases, but it isn't strictly just like we do, where we have 10, 10 squared, 10 cubed. So it's written vertically. I'm going to say that right now, and then I'm going to go back and talk a little bit more about their base 20 system. So in one place, they've got the place values of the ones. This is the ones place. Okay? They actually stack from bottom up, so the smallest value is on bottom, and then it gets bigger as you go up. So the next place value is a place value of 20. And you might be thinking, okay, that's what I thought it was, because you just said it was base 20, and that would be right. Here's where things go a little bit wonky. The next value is not 20 squared, it's 20 times 18. And we're going to talk about why. So if you can do it in your head, great. If you can't, grab a calculator. What is 20 times 18? 360. Any guesses as to why they might have liked 360? We use it for circles, but there's something else. You're right. It's approximately the number of days in a year. So it's the Mayan calendar stuff, right? They're the ones who are known for the calendar, and we're still all here, so, you know, that's way to go Mayans. But yeah, it's a calendar issue, right? And not really a calendar issue, but it's a year, you know, the length of a year is what it is, approximately. So that's where that 360 is coming into play, is because of that length of a year idea. Now, the reality is that we don't really care all that much, but we just need to recognize that there's only going to be 360 in that place value system. It's really not going to come into play a lot. I just want you to recognize that it's a little bit different. What they would do next is that they would then multiply their 20 out again. So then it would be 20 squared times 18, and then 20 cubed times 18, and so forth. Any idea why they're using 20? Y'all know, because I mentioned it before.
Fingers plus toes.
Fingers and toes. Yep. This is a civilization where they're going to see their toes, right? Yeah, it is. Yes. All right.
So in math class, you like get through those.
Maybe. See, you're going to do just fine, Devin. You got your sandals on today. Here's the other thing. So just like with the Babylonians over here, we have this natural break in some places where something has to change from smaller to larger. They have that too. They've got their bars, and their bars go beneath their dots. So for instance, if they wanted to do the number 8, that would be a 5, and then they put the 3 dots on top. Okay? So then if you see a bar on top of that and something else goes on, that means necessarily the place value changed, because bars go beneath dots. So if you see a bar on top, you changed place value. Okay? So we're, again, only going to put in as many place values as we know for sure have to be there as we look at their numbers. So let me do an example, and you'll see how that kind of plays out. All right, so I want you to put 2 dots with 1 bar underneath, and then 4 dots with 1 bar underneath. Now, just for fun, and again, you're not going to be asked, I don't think, in your book to actually do what I'm about to show you, but let me just show you how it works in terms of thinking about their number system. for sure, we know, this part you'd have to know, that the break has to happen there. That's a minimum number of where it changes place values. Has to change there because bars do not go on top of dots unless you've changed place value. So count with me. What is on top of my purple squiggly line? How much is up there? 7. Good. How much on bottom? 9. So this is the equivalent to having 9 $1 bills, or even you could think of it as being 1 5 and 4 1s, because the way you see the 5 right there, like the bar, and then the 4 1s. But up here, this 7 is 7 20s. That's the 20s place, and this is the 1s place. Okay? That's what we do in our system too, right? We have the 1s place, and then we have the 10s place. Right, and we talk about $10 bills there, or blocks of length 10, depending on what manipulatives you're using. So this is equivalent, and if we went up from there, if we had another bar, another row on top of this, whatever's in that row would be that number of 360s. Imagine you had a bill that was worth 360, right? So if there's a 6 in that place, you'd have 6 $360 bills. Okay? All right, the two questions are just like before. What number comes before and what number comes after? Now, in this one, the number that comes before is the easier one. Any idea what the number that comes before might look like? Good. Okay, so we need to take a dot away because a dot's worth 1. And Rachel's exactly right. It needs to come off the bottom because the bottom row is our lowest value system in their system. So we're going to take a dot away from the lowest value. So we're going to have 8 on the bottom, and then those 7 that were on the top are still on the top. Okay, so I still have my 7 20s, and I still have my 1 5 and 3 1s, and I had given away a 1. That's what's going on. Yes?
So like an R, like if you were converting what you did up there, it'd be like 149?
That's okay. So you the same thing. What?
Yeah, if you wanted to convert to figure out how much it would be, you would take the 7 times 20,
Okay.
and then you'd add the 9 times 1. Yeah, that's right. 7 20s and 9 1s. Exactly. The number that comes after, it isn't so much that it's really, really hard, but it's going to create something that looks a little awkward. So what in the world would happen on the next one if I want the number that comes after the number I started with?
2 dots and 3 lines.
Okay, so let's first recognize that the 2 dots in the bar above don't change, okay? I had 9 below. So if I had 9 below, now I'm going to have 10 below. The question is, how do I write 10? 2 bars. So I'm going to write 2 bars, because that's the number 10. What happened then?
Where's the place value change?
Yeah, I mean, you cannot see where the place values change now, can you? That's kind of a problem. I mean, this number down here now could be read, like we said, as 7 20s and 10 1s. But it also could just be read as 17. Or maybe as 13 times 20. That would be if you associated these pieces as the top value and then 5 1s after that. Now, what it can't do is it can't be 17 times 20. If it were 17 times 20, you'd have that place value down here with the shell as a place value. So you wouldn't have 0 in some place and not know it. But you definitely still have big issues with what in the world do I do, or how do I designate that there's a place value change here? Nope, because a clam isn't like a comma for us. If you changed, if you put a clam in right here, it would actually be saying that you have 0 20s, and then what's above it would actually be times 360 then. Good question, yeah. Obviously got some problems with this one too, right? There's a reason we don't use these systems in our number systems now. All right. There's one more number system that we're going to mention. And this one you actually do see still used today. It's a Roman numeral. So let's pause for a moment and let me ask you, where do you see Roman numerals used today? Give me some examples. Clocks. What else? Books. Movies. Like what? Give me an example of what you mean. Okay, like a movie title.
Oh, and online too. Yeah, they do.
Okay.
On when you're making an outline.
Outlines, yeah.
Sometimes in math.
Sometimes in math. Like today, that's right, exactly. Yeah, you'll see them used in suffixes after people's names. Like the men who like to name their children all after themselves, and they keep doing that. Yeah, they do that sometimes. Sometimes you'll see them if you go. We don't live in a state that's terribly old compared to the rest of the United States, but if you go back east, you'll see them on buildings sometimes. When the building was established, when it was built, you'll see that sometimes. My brother-in-law got married in the church that George Washington's funeral was in, or something like that. It was a very, very old Presbyterian church, and it was dated with the Roman numerals on the outside of it. Yeah. So there's actually quite a few different places. There's one more that nobody's mentioned, and that's probably partly because we don't have any boys in the class. Football and Olympics, Super Bowl, things like that, yeah. So you do see them sometimes done with that there too. All right, so let's talk about Roman numerals. Probably some of them you remember, and probably some of them are ones that you don't see enough that you might not remember. This one you remember. How much is this one worth? 1. And sometimes you see bars on the top and bottom. So you can write it like that, or you can write it with bars. It doesn't make any difference, okay? The next one, do you know what it is?
V.
It's a V, and it has the value of? 5. Great. We're on a roll. What's next? X. Value of? 10. Does anybody know what comes next?
There's a C.
There's a C. There's an L. L's next. L's worth 50.
Does it have bars in it?
Yeah, you can put bars on all of these. It's sort of like a...
But if you put bars on the L, it's going to make it look like a line.
Yeah, it would look really weird. I don't know. I don't put bars on any of them because they aren't really needed. So I just leave the bars off completely, yeah. All right, so somebody mentioned C, which is actually next. C is 100. Do you know? There's 2 more.
Isn't there a B?
Not a B. There's an M, and there's a D. D's first. D has the value 500, and then the last one's M, and that has the value 1,000. And they do have a way to make a number bigger than 1,000. So, give me just a little bit, and I'll show you how we do that if it's something bigger than 1,000, okay? All right, so these are the symbols. As with all of these symbols, I'm not expecting that you'll memorize these. I mean, some of them you probably just will remember, but you can put them on a note card for your test, things like that. So, just have something with you as you're working so that you don't have to keep flipping back and forth between your notes pages or in your book or whatever to remember which one's what. All right, so a few things about the Roman numeration system. Well, one thing to just notice, just looking at these numbers, what do you see? What was that?
Letters.
Letters. Okay, they look like our letters, actually, but something else. I mean, they're values. That's what I meant to say.
Between 1 and 5.
They're always numbers of 1s and 5s, right? So they're powers of 10s, and some of them have, and then there's other ones that have the half of that amount. So if we have 100, we have 50. We have 1,000, we have 500. All right, so they have a couple of properties that we need to be aware of. One property is the subtractive property. And you're familiar with this one because if you wrote the number 4, you would not write 4 ones, right? You would write IV, right? And not like the hospital IV, but I and then V, right? So you would write this number as IV, written here. The only time you use this property is if you're dealing with numbers of 4s or 9s. Okay, so you don't do this with the number 8. So for the instance, with the number 8, we would write VII. We would not write IIX. Okay? So I'm not saying that there wouldn't be maybe like, I wish they did it that way. The point is they didn't do it that way. So we're going to do what they did. Does that make sense? Okay, so they would write it like this. They would not write it like this. This doesn't work. So for instance, if you take the look at the number 90, and this works for anything with, it doesn't have to just be 4 and 9. It also works for 40 and 90 and 400 and 900 and so forth. So if I looked at the number 90, how would I write the number 90?
Did you do it like that? XC?
Yeah. So the number 90 would be X and then C. So you only use the number that's one place value less than what you're working with. Okay, so 90 is close to the number 100, agreed? So you're actually going to be thinking of the number here in this place, the 9. So you're saying, yep, I'm going to use a subtractive feature. That number 9 is nearly the number 10. If this were the number 10, I'd have 100. What's less than 100? Well, that would be 10 less than 100, so I've got 90. So I would write X and then C.
You know it's subtracting because they never write the lower value before.
Correct. They always write the lower value before, if and only if it's subtraction. Yes.
So if we were going to do like 80, it would just be LXXX. Like
Yes,
50 and then
exactly.
30.
Yeah, so if you wrote the number 80, it would be 50 and then 30 more.
Okay.
That's exactly right. This would be the number 80. Now, we can't do this, unfortunately. You know what I'd really like to do for 99? I'd really like to do IC. They don't do that, okay? The place values are all separate, and they only go one place value less than what they're at. So if you take a look at this 9, it's going to be done just like I did with the 90 before. It's XC. That's how I get 90. And then how do I get the number 9? IX. So this piece gets me 90, and this piece gets me 9. They have one more cool thing that they do that you may not be aware of. The other cool thing that they do that you may not be aware of is they have a multiplication property, and this allows us to use values that are bigger than 1,000. So what they do is if they put a bar on top, and I don't mean the bars that touch like the ones we were talking about, but a bar that's a separate bar on top of the value, it means times 1,000. All right? So if we just did the number that we had before where we did XC and we put a bar on the top, it would mean 90,000. Okay? So this would be 90, and the bar means 1,000. It means times 1,000. So it would be times 1,000. So this would be 90,000. I actually think of that bar almost like we think of our commas. You see one bar, you're going to have a comma after it, and it's going to be, whatever's next. Now, if you want something bigger than that, you can go into millions, and you can put 2 bars on top of it. So double bar on top means you're turning it into millions. Whoops. So if you had, for instance, that same XC, and you put 2 bars on top, instead of being 90,000, it would be 90 million. Okay? And again, do you see how I'm kind of thinking about those commas? Look, 2 commas, 2 bars. That's how I think about them. I think it works pretty nicely to correlate that way. Now let's say we wanted to write the number 9,000. What would I do to write 9,000? Do you have an idea, Katie? Right, so 90 is IX. That's the number 9. I'm sorry, 9 is the number IX. Let me say it right. And then to make it 1,000, I would write the bar on top. Now there is one sort of weird, awkward thing that goes on here, because we do have a symbol for 1,000, right? So like, what if we had 2,000 or 3,000? So, right, 2,000 would be written as MM, because that's 1,000. And 3,000 would be written as 3 M's. And 4,000, how might that be written? C is worth 100. M is worth 1,000. Did that give me 4,000? Not quite. Right. What do we have? I think that's where we stop, actually, now that we got there. We ran into a problem with the 4,000. Yeah. So if we get past 3,000, where I wouldn't write 4 symbols. That's something they would never do. So when I get to 4,000, we're going to do exactly like we did with the 9,000 here. How do I write the number 4? IV. And then how do I make that into 4,000? That's with my bar. Okay? It's a little different.
So whenever it has like the regular, like if they have bars on top of one, they'll do an extra one on top.
Exactly, right. Like if they wrote this, it would look something like that. Yeah. Have another bar on top. I guess maybe that's probably why I also don't write them, because it can start to look a little bit awkward. All right, we will pick up with example 4 next time.